Have you ever wondered how a simple press of a button can capture a breathtaking sunset, a child's laughter, or a once-in-a-lifetime moment? You press a button, and just like that, the camera freezes time. But how does this small device turn light into a memory you can keep forever? The answer lies in a fascinating combination of physics, engineering, and digital technology, all working together in perfect harmony. At its core, a camera is like an artificial eye. Light from the world around us reflects off objects and travels in all directions. When you take a photo, you're actually gathering some of that light and directing it through a lens. The lens is a curved piece of glass or plastic that bends and focuses the light to create a sharp image. Different types of lenses, such as wide-angle, telephoto, and macro, provide unique ways to capture the world. Without a lens, the light would scatter randomly, and the image would be blurry and unclear. Just like how our eyes have a cornea and a lens to help us see clearly, a camera lens is responsible for shaping the light into something we can capture. Once the light passes through the lens, it reaches the aperture, which is an adjustable opening that controls how much light gets in. If you're in a bright environment, the aperture shrinks to let in less light. If it's dark, the aperture widens to allow more light in. This works just like the pupil in our eyes, which grows larger in dim light and smaller in bright light. The balance of light is crucial because too much or too little can make a picture too bright or too dark. After passing through the aperture, the light moves toward the shutter. The shutter is like a tiny curtain that opens and closes very quickly. When you press the shutter button, this curtain moves, allowing light to hit the camera's sensor or film for a brief moment. The speed at which it opens and closes is called the shutter speed. A fast shutter speed can freeze motion, like a bird in mid-flight, while a slower shutter speed can create a blur effect, such as streaks of light from moving cars at night. In older cameras, this light would land on film, a special strip coated with chemicals that react when exposed to light. This reaction captures the image, which can later be developed into a photograph. In modern digital cameras, the film has been replaced by an image sensor, a small electronic chip that records light instead. There are two main types of image sensors: CCD, which stands for Charge Coupled Device, and CMOS, or Complementary Metal Oxide Semiconductor. These sensors contain millions, sometimes even hundreds of millions, of tiny pixels, each of which collects light and converts it into an electrical signal. The stronger the light, the stronger the signal. Once the sensor collects this information, the camera's processor steps in. The processor is like the brain of the camera. It takes all the electrical signals from the sensor and turns them into a full-color image. This process happens almost instantly, and the result is stored on a memory card, ready for you to view, edit, or share. But what about color? Light is made up of different wavelengths, which our eyes perceive as different colors. The sensor itself doesn't actually see colors. It only detects brightness. To capture colors, cameras use tiny red, green, and blue filters over different pixels. Then the processor combines these filtered signals to create the full spectrum of colors in the final image. This method, known as the Bayer filter system, is how digital cameras recreate the colorful world around us. The quality of an image depends on many factors: the lens, the sensor size, the number of pixels, and even how the processor interprets the data. Higher-end cameras allow photographers to adjust settings like ISO, which controls how sensitive the sensor is to light. A higher ISO helps in low-light conditions but can make the image look grainy. Balancing all these elements is what makes photography both a science and an art. Beyond still images, cameras also record videos. Video recording relies on frame rate, typically 24, 30, or 60 frames per second, to create smooth and natural-looking motion. Instead of capturing a single image, video cameras take many pictures in rapid succession, typically 24, 30, or even 60 frames per second. When played back at high speed, our brains perceive these frames as continuous motion, creating the illusion of movement. With advancements in technology, cameras have evolved dramatically. Smartphones now have powerful cameras that use artificial intelligence to enhance images, adjust lighting, and even recognize faces. Meanwhile, professional photographers use DSLR and mirrorless cameras with interchangeable lenses for greater control over their shots. Even in space, special cameras like the Hubble and James Webb Space Telescopes help scientists study distant planets and stars, capturing images our eyes could never see on their own. A camera may seem like a simple tool, but beneath its sleek design lies a remarkable system that mirrors the way our own eyes work. Every time you take a picture, you're using the principles of light, optics, and digital processing to turn a fleeting moment into something permanent. Whether you're capturing memories with a phone, a professional camera, or even an old film camera, the magic behind photography remains the same. It all begins with light.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.